George is on break. He won't be joining today. So we can get started. So first thing, starting from next Monday, we will push this meeting back by 3 hours because we will be in Asia, and that time works better. I will put an announcement in this channel and update the event. Speaking of the event, I can start the event. Okay. What else for company update? We usually talk about how many bucks we sell. I think we sold a few more, so that's about it. I don't know if Wosper has any update for the provision machine or anything regarding provisioning.
Not really. The machines are gone, so good.
Oh, okay. Is that good? I don't know. Okay. And what's the company update? And next, basically the main point and what everyone has been doing for the past week is Rangify. For the people in this meeting, Rangify is it's a new, I guess, paradigm shift for Tinygrad that we are trying to fix every bugs in it so we can make Rangify the default. Rangify leads to all the advanced fusion, the local buffer support, flash attention, and friends. So we really want to get this working and basically pass everything, and that we can start to remove a lot of stuff. So I just list some, I guess, issue or the things that I can think of here, and we can basically go through that, see if people have ideas for what it is. And we can start with store and assign. I think, I guess, also copy. Maybe Osman has some ideas for what's the current state of this. Are things broken? Are there like hacks that we need to remove first, or any other like open issues?
I fixed copy. Copy should be fixed if there are any, let me know. But yeah, I'm working on multi right now. For copy, it wasn't just like realizing things correctly. So that was also the issue with the jet.
Maybe we just briefly go through like what was the issue. I think we can break down issues in terms of there are some hack, and or things are not complete, and or there's just something that we don't understand.
It's mostly that things are incomplete. So in the original Rangify design, it only put back buffers into the graph. That's not always true. You can't, like, sometimes you need to put constants back into the graph. Sometimes you need to put a view of a buffer back into the graph. It's different from the original structure. So for example, you can imagine I have a buffer and then I expand it and then I copy it. It's wasteful to do the expand before the copy. What you want to do is you want to copy and then do the expand on the other device. So that like range of I then have a way to specify that or express it. I removed the hacks that dealt with this in the wrong way. It's basically just a question of, because UOPs are currently immutable and they should be immutable, you have to update the pointer of the tensor. So after, for example, you do a plus b and then you call realize on that, I would expect that that tensor would become a buffer. The way we currently deal with this is we have a pointer of a UOP in the tensor, and then we just swap up the add with the buffer. So this was buggy in the old scheduler. It's showing cracks in the new Rangify stuff, which is just like a sign of this is an inherently hard problem. But yeah, I'm going through the fixes.
I
Currently,
think
I'm
there
working
are,
on. Yeah, go ahead.
sorry, back to the sign. I think there are still issues for external tests schedule or something. There's like a permuted assign and something still wrong.
Those are mostly asserts. Like if you have a cycle, we used to assert that you had a cycle. Now we just
Yeah, so I think
You're
for
right.
now it doesn't have assert, but the output is wrong.
correct. It gives the wrong answer, which it shouldn't. The path forward for assign is either fix it and never uh, assert cycles, or assert cycles like the old scheduler. So you actually like in Rangify is nice because you can insert buffers right before the cycle would happen.
Okay. I think generally when I go through the fail tests or the things that still fail with Rentrify, it's the things that runs but the output is incorrect. That's very bothersome. And I think that's yeah. I think because the next one is group reduce, and I think group reduce is currently suffer from this. So C's fix some of the linearizer failure to that case, but I think group reduce is still wrong.
Yeah, so yeah, it's not giving a linearizer error anymore, but we're not properly putting like the problem, the case that's causing a problem is if you have a group reduce inside of another range, like inside another reduce. Um, so what happens is after the end of the group reduce, you have a if statement so that the shared memory is reduced by only one thread. And then once you're outside of the range that's surrounding the group reduce, you need to be inside an if statement again because you've closed the like local range, um, which is a bit tricky.
I see. So I
As
see
the, I
that you are
mean, my
fix the
I'm
issue. Let's see if we can. Sorry, go ahead.
like I was kind of thinking that we don't. I'm not sure we actually need the if statement because if all the threads just do the same
Oh yeah. So that's another thing
sum,
that I think we discussed like long time back. It's like there's nothing wrong if all the threads are doing the work anyway.
yeah.
It's not like you will get faster. So I think
Because
that's
now, I mean,
fine.
now the problem is that some of the threads are doing a sum and some of the threads are not doing a sum. And then if they all try and write to the same address, then on NVIDIA right now it's correct because it writes the first element, which is the one that did the sum. But on AMD,
I don't think that's a
uh,
big that we can rely on anyway.
no, okay.
So I think see if you can add an arrow in this case, some custom arrow. I think the before like merging Rangify as a default, I think the order is we definitely want to get rid of all the silently wrong outputs by like replacing that by some custom arrow. That's fine, and we can fix that. At
Right.
least we
Yeah.
at least we understand that under this condition, it's an arrow that we throw some arrow, then we can later decide maybe there's some issue with the spec or something's not complete, or we need to change the render to like render it differently, like without like removing the if or something like that. But I think the good first step is to see if we can like always raise an issue saying this is not supported.
Yeah.
Okay. Disk. I feel disk was fixed as part of a copy. I think there was an old issue that if you open something on a disk, then you try to code .numpy, it would fail because it will say some kernel needs to be run on disk, but disk doesn't have capability to run a kernel, something like that. I think it's mostly
I
gone.
have to fix disk because it blocks my copy stuff. Yeah. But the fix I have is basically exactly what the old scheduler was. So if WAS wants to look into the disk stuff, there's a to-do in grangify.py for disk. It's using shape tracker. You up that shape tracker. It shouldn't. It should just use the shrink. And there are still pending stuff in Tensor as are disk hacks, but none of them are Rangefy related. Most of those are just things that have existed long ago.
Was per did you
This
get a
is-
chance to check disk?
Yeah, I looked at disk briefly. The one issue I did find was that it was trying to run kernels on disk.
Yeah, that was the issue, and I think that's fixed. If it's just a copy, like copy the underlying buffer to a NumPy buffer or something.
Yeah.
Okay. So I think the remaining disk one is probably just like cleanup that should be done.
Yeah, I think just remove the ST call, like use proper shrink and stuff. I really didn't put much time into this.
Okay.
But yeah, the core idea is there.
Yeah, I'll take a look.
Disk Nexus bit. I think you probably also mentioned something was fixed, or I think Nemogen also did some fix on test JIT. So the symbolic JIT is fixed by seeds mostly. Then the JIT itself, the copy, the JIT is also fixed. I mean, there are still some issues that JIT will return you the wrong shape because it doesn't update the shape for symbolic. But that's kind of the same behavior. We have test. Yeah, so I see test JIT is in Rangify test. I think, are we all good there?
Yeah, actually, the JIT problems were related to Israelized as well. So the same issue copies.
Is it still not realizing inputs? I thought I fixed all
No,
that.
no, it's good now. It's good now.
There is a problem with GPT-2 is producing the wrong output. Is anyone looking into that?
I'm going to do that, but maybe it's because of the group reduce. If we have any problems with it, might happen with GPT-2 as well.
Yeah, let's see if we can quickly raise some error for group reduce. Then we can like don't do group reduce for Rangify as a next step. After we understand the issue and the triggering criteria, we can kind of disable that first so that at least the output is correct. I think another thing related to LLM or GPT-2 is I think it's fusing the rope embedding so that it has a very big buffer and very slow.
I mean, I think in
Yes.
general, the Rangify is fusing like a lot.
So I think if the issue is the cost function to decide like what to fuse and what not to fuse, then we can decide there. I think for rope specifically, I don't know. We'll get there. I think let's prioritize the correctness first and like fix the issue. If it's like just optimization for speed and not a correctness issue, we can wait. Or I guess. that's the last thing before we make this the default. So we fix the error first. We make sure we understand the behavior, and we fix all the correctness issue. Then see like after that, to get a good default, we need to make sure it's performant. Then there we can optimize the cost function and stuff. Next is const folding. So I was looking into the const folding reduce. I have a PR that I just delete a bunch of stuff and nothing really changed, and I was really confused and not happy about it. I think the issue there is, well, this might be related to the image one. So in image, this is generally a problem with index. I think some rewriting rules, we just cast things arbitrarily, and if something should be in a D-type index, but we cast it to something that is not D-type index, then the whole thing becomes not D-type index, and later you have an issue with some ALU. So I don't really understand this, but I think it might be related to image. And I also think some of the cast thing, I don't understand the scope of this well, but we have some tests that the arrow is the last length is not defined between invalid and issues like this. Okay, I will probably continue looking. I think Kotlin also expressed that we want to delete everything in the section 0 rewrite. Some of it was causing problems.
We do. The tags are so hard to deal with. The tags just disappear from the graph and then nothing realizes. Yeah. There are some good stuff in there. I know the reduce folding exists in there. I think I should remove that too.
Yeah, okay. I will see what I will see what I can do with const folding and other folding stuff. I think generally I find the kernel count errors to be on the good side, like something that was not handled before now is handled and properly fused. Some of the remaining ones for model, I think I would change that at the very end. Again, that's more of a what's the default cost function for when to fuse, and I think as long as it's correct, we can always test those later, so that I worry less about. Okay. Next is buffer limit. I believe we don't currently implement this, so that for Metal Web GPU, some tests fail because of that.
Yeah, and probably I can take a look into this.
Okay. Sounds good. LLM, we already discussed. Let's disable group reduce. LLM, I think this is the issue is it's fusing too much stuff and it's slow. So as long as the output is correct, it's correct on the Rentify equals to 1 PR. It's just 10 minutes to run. So I think we can wait. The open pilot, children not making progress. This I don't know if anyone has something to say about this. I don't know.
I believe that's related to pad. At least that was the case for Vinaigrette. Map pad isn't cached right now, so it keeps calling it. And it never actually resolves. At least it hits the 10,000 limits of the identify. I'm sure it will resolve at some point in some distant future. We should catch that thing. Can be.
But I mean, the cache that I think we talked about is just for symbolic, right?
Yeah.
But should that affect the the children not making progress?
So because like the threshold is that if you come back with an index with two children, for example, and one child hasn't yet finished doing the indexing for 10,000 times, you'll end up getting an error. As that's what I got from undergrad, where MapPad would keep on calling itself and not resolving in the end.
But is MapPad like actually calling itself?
I don't know if it's calling itself, but like at the graph rewrite loop level, something keeps calling MapPad. Do you think that's not the problem here? I think that should be it. Every time I control C, it's hanging in MapPad.
Wait, yeah, but I mean, the times I looked at it, it was just one single really long MapPad call, and that's because I mean, I did like I tried to cache, and it's a bit faster, but it's still like the U of government valid is just pretty slow if you have a very big valid with a lot of expressions and a very deep um, index. I mean, like a single call to MapPad should pretty much entirely simplify the index. So I don't think MapPad has been called many times. Like it might take a long time in MapPad, but I don't understand how that would cause like children not making progress.
Okay, I mean, I don't think we have an answer now. So that's fine. Let's see if we can find other examples that is causing this issue and what we're going to do next. Okay. So image we discussed before. There was some index issue that I don't quite understand. But again, image is quite isolated as a feature. So maybe if we fix other issues, it would become much easier to understand what was left. Okay. See. Is there anything I missed that the issues you are aware, but I didn't list it here? Mm. Okay. For the things that we did fix, I think most of the Annex stuff is fixed. The high level tensor stuff is looks good. We added a lot more tests. Also, I just added the Mac OS for Metal as well, while knowing that sometimes it works for, especially OpenCL is, I don't know why it's different. Sometimes OpenCL one fails in one of the Metal and Linux version, so I just added. Anything else for Rangify? I guess that means no. Okay. Okay. anything else that you were working on that I didn't include?
We can give a little
Okay,
stats
no.
update.
Oh yeah, what's the? Is it working now? Oh, it's working now. Okay. What happened?
It's working, but we don't have historic data.
No.
It will be back. Historic
What do
data
you
will
mean?
be back. But so
Oh,
as of
okay.
right now, the database that we use for stats is InfluxDB.
Okay.
After the power outage, the database corrupted.
Okay.
Great. But that was a pretty easy fix. And I also thought I'll do a minor version bump. And then the
Or
problem is for the database.
okay.
And then there's an open GitHub issue on Influx right now, but on all versions past 3.0, for some reason they just hang when starting.
Okay.
So I'm currently unable to start the database when it's pointed at our old data.
Okay.
So until upstream fixes that issue, our old data is not accessible.
No. Okay. I think that's fine. I mean, as long as the new data looks fine, I think it's fine. We can discuss later why or which database we should be using next and stuff like that. But now it seems to be working.
Yeah, I'm migrating to something else because Influx is also there's another issue, which is that we can't fetch any data past 12 days.
Great. Why? Okay, I don't know.
It's some
Okay.
limitation they have.
Okay. Great. So the current status is new data should be fine and the website is fine.
Yes, old data exists, just not accessible right now. New data, this is currently it's just temporary while I set up a new database, and then I switch it sometime this week.
Okay. When you say old data, like when was the cutoff?
Cutoff was whenever power went out at the office last week.
Okay. Great. And did you update all the Rockham compatible thing to Rockham 7?
I've not yet. I've been quite busy fixing provisioning because it's been broken for the past week.
Okay. Cool. I think that's fine. I don't know. Probably fine this week. We can discuss
But
next week.
I'll bump it before Hong Kong.
Okay, sounds good. Okay. Cool. Sounds good. Okay. Other bounties. I think the most notable one is trending stable diffusion. Where is my wrong? My wrong is still going. I mean, trend. It seems like I have a trend model. So, that's good.
Yeah, you should have the eval result for the last checkpoint within like 1 to 2 hours, probably like 1 hour-ish. And then it'll keep chewing through the checkpoints in reverse order.
Okay. Let's see. Cool. Yeah, I think this is nice that we have something trend. I mean, I definitely want to understand the crash better and see if we can like beam something that's not 6 hours. I think in the spirit of bounty, unless there's something that's very slow, we want this end-to-end to be within 24 hours. I think that's the spirit. Now we have a much powerful machine, but the task is also much bigger. But now since we know it's beaming for, I don't know, 7 hours or something, I think reduce that so that the total end-to-end time drop to 24 hours seems reasonable.
Yeah, I mean, probably most of the compute, even if we drop beam down, is going to be on the eval. So does that 24 hours just include like, the first eval result, which would probably tell you whether it converged or not?
I think it was really enough. I mean,
Okay. Yeah, I can play with. I guess my question for you is, I noticed the beam parameters. There's like some very specific ones about like the number of UOPS and stuff, and I'm guessing that you arrived at that somehow. Are there any tips there? Like that's probably the key is just playing with those to rule out any kernels that are, in addition to dropping the beam down. The main issue, as I wrote, is like with beam equals 1, there's just kernel or sorry, driver faults. And so
yeah.
maybe I can play with it.
So I think this would be really helpful if you can pin down like which kernel code at what stage. Because first, it's very weird that once you rerun the pipeline, the next time it passed, it seems like either there's like memory leak somewhere or we have buffer that's not cleaned up properly. Because it doesn't make sense if you beam a kernel, it fails the first time, then the next time it works, right? So
Yeah,
I
no,
think
I agree with that. So there's multiple issues. What I was just talking about a second ago was like not related to memory. It's just related to driver fault,
yeah.
but you're talking about memory. So I have in the past pinned down the ones that cause the driver faults, like the exact ASTs and optimizations. I could do that again for the bus errors. But for the actual out of memory stuff, like it's just, as I said before, it takes hours to reproduce that. There is some kind of memory leak. I'm not sure how tractable that it is for me to debug.
I see. Okay, I think yeah, that's more of a Tinygraph core issue, less of a like a used Tinygraph issue. So I think as long as the script can end to end like recover and show that it still works, it's like less. It's not ideal, but at least it works. I think that's nice. And back to your question for the bin parameters, it really depends on the task under the hood. I don't think we have a very good default there. So usually it's a trade-off between do you want to look for things that has a lot of local or upcast expression or not? That's essentially what those parameters are. Usually for every parameters, it's a trade-off between the speed versus the search speed, the search time versus the output kernel speed. Since here, I don't know, you say we have like 10x performance gap between in terms of utilization. I imagine that just means a lot of kernels we are not doing well anyway. So I think focusing on good enough parameters that search not as many but still good enough in terms of end-to-end time would be like practical here.
Okay.
So
Yeah, part of that 10x is the power limiting, which might not be an issue on TinyAMD2. So I could test that. It might shrink down to like less than that. And then also, yeah, I'll just play with all those parameters.
yeah, so
And
I think at the end of the day here, what we really want here is if we can first find the exact AST and optimization so that it crashes the machine, because that's very valuable for us to fix that we need to fix anyway. I would say like don't worry too much about the power limiting and effect from that. Yes, it's not that big of a deal if at the end of the day it's just that. But for now, it's like searching multiple hours, which is not ideal. I want to fix.
Okay, yeah, I'll look at that. Thank you.
But directionally, really happy that this is working. I know it's like hard. For the changes that touch core Tinygrad, you can make a decision if you think it should be included in the core thing. I know there are some detect changes. If you find the corresponding behaviors in Torch or Jax, I think we will consider that and add it to the core implementation. If not, you can have it as your custom. That's also fine. So basically,
yeah,
see other than the main loop, see if there are things that you want to be included separately. And I know some of the D type upcast downcast it's a hack because the way we previously schedule and fuse kernels that was maybe just faster without sacrificing a performance. And if you find there's a mismatch between implementations that we should consider, we should definitely consider. Okay. Sounds good. Any update for RetinaNet?
Yeah, so I was looking at the eval script more. I think when I ran, so I think what I'm running into right now is with JIT not working with the mass select, because that's a pretty common use case for the eval script itself. So when I hit it, I think because I know there's a realize that happens inside the mass select implementation itself. So I found that it looks like it's caching the value after you do a couple of runs of that JIT function. So that's when at that point when the Tinygrad rewritten version versus the current NumPy implementation does it match? So that's something I put up I think last week. I'm still working through if there's another way to do that, but if I just disregard that issue for now, I think I still find the Tinygrad rewritten version a bit slower, or much slower than the NumPy implementation. So I'm trying to see if there's a better way to batch the eval itself, because there's a couple of loops that kind of go through the predictions. So I think there's like the actual per batch loop, and then also inside of that there's also where they do splits and then they consider different levels on each of those predictions, and then that's when they start doing a lot of the operations from there. So I think those kind of like the two main issues that I really want to try to solve.
So I am reading the mask select implementation. I don't see any realize here, but I do notice that the counts in that function doesn't have device specified. So I think that might cause issue.
Oh yes, I think also I was trying to do the multi GPU case. Yeah, there is something that's not working there, where it's complaining about the devices should be in the same, or like all of the buffer should be in the same device altogether as well.
Well, yeah, so those we definitely want to fix. And if you notice these, feel free to open a separate PR that fix this with some test. That will also be really.
Yeah, and also going back to the realize one, yeah, I think there was I think there's one line on the code there on the mass select implementation where they do the dot item actually. So that's when they create the I guess the accumulator, I think for getting the indices. Yeah.
Okay, now I see it. Yes. We should not be doing. Okay, I don't understand. Isn't this just a sum or something? Okay, I don't know.
Yeah,
I can take a look, or you can take a look. I think this needs to be fixed. The device definitely need to be fixed, and we shouldn't go realize or latent if we don't need to.
Okay, sounds good. Yeah, I'll talk to Azibo Copy about this because I know he worked on the initial implementation, and see if we can kind of whip up something together, and hopefully we can remove that I guess that dot item call there.
Okay, sounds good. Okay. Anything else we should include? B1TG, are you working on anything?
FP8 bounty.
Mhm.
And the last part is get the
Yeah,
Tensor Core
Tensor
works.
Core.
Yes.
Mhm.
I don't get access to the red machine. Maybe I can get access to one.
Oh, sure. Wolfberry, can you add him to, I don't know which one supports FP8, but add him to whichever.
On the gray machine.
Okay, we will figure this out and get you access to a machine.
Okay.
Cool. Anything else? Checking the bounty sheet. Checking the PR. Okay. Oh, I don't have anything. For other people in this call, anything else? Okay. So I think that's about it for this meeting. And next week it will be pushed back by 3 hours. And that's all for today. Thank you, everyone. See you next week.